Hello, everyone. This is Spencer from Hydromantis, and thank you for joining us today on our monthly GPSX webinar. So today, the plan is to talk about sequencing batch reactors. So this is a repeat of a webinar that we did many years ago. It was actually one of the very first webinars that we ever did. And I thought it was a good time to sort of update this webinar now that in version 8 of GPSX, the menus have changed in the SBR. So it's a good time to sort of review how to set it up, what the important things are to know about your SBR setup, and what the important parameters are, and indeed, actually, which of the 3 SBR models that we have is the one that's the correct one for your job. So my name is Spencer Snowling. I'm a VP of Product Development here at Hydromantis, if you have not met me before. And the plan for the presentation today is to talk a little bit about the background of the SBR model, kind of how it works, what the important parts are, and a discussion around the idea that we have these 3 different SBR objects that you can put on your GPSX drawing board. The simple one, the advanced one, and what we call the manual one. So each of those has its own unique properties, and we'll talk about that. We'll talk about how to properly set up an SBR cycle. And also I'll, of course, as I usually do, run an SBR simulation in GPSX version 8. And then, as I mentioned, you can type any questions that you might want to in the chat box, and we'll or in the questions window, and then we'll answer those at the end. Excuse me, I apologize. I'm in being a somewhat poor voice today. I haven't really been able to quite shake this cough that I got over the Christmas holidays. So if you hear a long pause and no voice, it's probably me coughing in the background. Okay, so the SBR is actually a really popular model in GPSX. I've actually really enjoyed modeling several different SBR projects that I've done over my career. I find it really an interesting technology. We've had them in GPSX since the very, very early days, since version 2, so way back in the sort of mid to late 90s, predating my time even at Hydromantis. It's really one of the most popular unit process models. We get quite a bit of people asking us questions about it. It's certainly one of the most powerful models because there's a lot going on there, but it is indeed one of the most complex models to set up. So really, the SBR model is a combination of a completely mixed reactor with all the associated biological reactions that go on in our typical CSTRs, along with a settler. So this object is unique in the sense that it switches back and forth between being completely mixed and not completely mixed. And that allows us to be able to switch between modes where aeration and other things are happening, and then switch over to a layered model. So you have vertical layers like you do in our one-dimension or settler models. And of course, all the sludge will settle, and then you can decant and so on. It has the same aeration as our CSTR in terms of the opportunity to use a DO controller and specify the details of the diffused aeration system. Excuse me. And then it also has the hydraulics of a variable volume reactor, meaning that you can pump it up and down as you need to do with an SBR. And so we keep track of all that flow going in and out, and et cetera. And then overlaying all of that is our SBR sequencing control system. By sequencing here, I mean the automatic sort of turning on and off of the various mixers and pumps and aeration system in order to perform that cycle at the right time over and over again. So if you drop one of the SBR units on your drawing board, it has an influent, just like any one of our tanks. Although it's important to remember in this particular unit, unlike our regular completely mixed tank, the influent isn't always on all the time. In fact, you only want to fill for a portion of your cycle. So the control of the upstream flow coming into the SBR object is important, and we'll talk about how to control that properly. The bottom connection point is typically where people would be doing their wasting from. The decant pump on the side is where you get your treated effluent from. And we won't be going into it in too much detail today, but just know that you normally would decant off the top layer as you're pumping it down, but you do actually have some control in order to be able to pump off of whatever layer you like, and also decant only down to a certain minimum volume, if you like. And then, of course, we have our overflow connection point. So now, theoretically, if you've got everything set up properly, it won't overflow, but typically that's where that would happen. So the input menus, in order to be able to control all of that stuff, are slightly different than what you would find a lot of other activated sludge tanks. And in fact, we have 3 different operational menus because there's just so many parameters there to deal with. So we broke it into different menus. And you'll see here, of course, that the tank size and things that you would normally find in the physical menu, those are there. So, temperature and all the other stuff that would specify the physical characteristics of the tank. Then we have one menu for setting the cycle settings. So that's the number and the order and the duration of the phases of the SBR cycle. And then we have aeration and flow control menus to do the aeration, pumping, filling, decanting, and so on. That's normally the things you would find in the operational menu. There's such a large amount of stuff going on here that we broke it into separate menus for aeration and the pumping controls. Then the rest of these are basically the same as what you would find in a regular biological reactor. You have your biological parameters doing the stoichiometry and kinetic parameters. The settling parameters, so you can control, and match to the settling of the flocks, and then an operating cost menu, which has mostly just energy costing in there. So as I mentioned, and if you open up GPSX and look to the left of the drawing board into the unit menu here and look in the suspended growth processes tab, you'll find that there are 3 sequencing batch reactors down here near the bottom. If you kind of have to scroll down to get to it. The one that's just called Sequencing Batch Reactor is actually the simple model that we use, and it has, as I'll show you shortly here, a fixed order of operations. So we have the Sequencing Batch Reactor, we have the advanced one that allows for quite a bit more flexibility, and then we have the manual one, which is one that you can use to do your own custom programming with. So let's talk about those in a little bit more detail. The simple SBR has a fixed order of phases, and you're really just setting the duration of those, but you have to make it operate in the order that it has. So we've picked, obviously, ones that are the typical SBR setup. You can actually skip over some phases if you don't need them. The advanced one, though, is one that has a flexible order. So it allows you to set any number of phases that you like, and you can do them in any order that you like. Excuse me. You can also change the duration, obviously, and the various properties of things that are going on in those phases. So, and the manual SBR, actually, there is no sequencing. Basically, it is just a completely mixed reactor or a layered one-dimensional reactor. You have control over everything, but you have to manually set all of those, either via code or what have you. So how do I know which one of these 3 is the right one for the job? So which one of these objects do I want to use? Well, it depends on, for the SBRs that you're trying to model, the phase sequencing. Basically, if you need more sophistication, you'll have to go to one of the more sophisticated models. So starting with the simple model, which is just called Sequencing Batch Reactor on our drawing board, you'll note here that there are 7 phases that exist on the operational cycle settings menu. And so therefore you can run the simple SBR with these ones in this order, and you can set whatever length of time that you want to have that happen. So over here, you'll notice that it says, for example, at the top here, the total cycle time is 6 hours. And I'm going to have it fill for half an hour and then aerate for, while I'm also filling for another hour and a half, and then aerate only for 2 hours. And then I'm going to have it settle and decant and desludge, etc. So you've got the schedule that will go over and over again. And if you may notice here, actually, this is 6 hours total time, but actually all of this stuff didn't add up to 6. Any other extra time that's left over is what we call idle, where there's basically nothing happening. So it's basically just either mixed or not mixed, depending on where you left it, and then it will just continue on that phase until it's ready to start at the beginning of all the phases again. So typically this covers, most of your typical SBR operation, and if this fits with what you're trying to do, then I recommend you use the simple SBR. Okay, so now the advanced SBR has all of the options to do that. However, we don't necessarily require you to do them in that order. So essentially you have as many phases as you need, and you can do them in any order, and you can repeat them over again or whatever it is that you need to do. Any combination of filling, mixing, aeration, settling, and decanting, and wasting. So basically you could, for example, do a filling phase and then have an anoxic period of time where you're just mixing. Then you could aerate, then you could go back to having another anoxic period and then aerate again. You could do that more sophisticated BNR type of stuff in an SBR context, but you would definitely need the advanced one to do that. And so you have to set a few more things to make that happen, but that flexibility is there for you. So the way you do that is you click on the cycle settings, and you'll notice now this is a different menu than what you saw before in the simple one. We've listed 10 phases here, and they have a duration, but there's not a specific pre-configured meaning or purpose to each phase. You can make it do whatever you need it to do. So in this menu here, you're basically just setting the phase. Here we're showing in hours, and then you can decide what you want to happen in each of those things. You also need to set over here whether that phase is mixed or not. So if it's a 1, that means it's mixed. So we're going to go in the CSDR mode. And if it's 0, that means we're going to flip over to the settling mode so that you can have the one-dimensional concentrations in your SBR. So typically that would look like for a conventional one here, maybe those first few ones you're doing some filling and mixing and aerating. And then these later ones, you're just doing settling mode and decanting and letting the rest of the system settle before you waste and so on. So lots of flexibility here, as I mentioned, to do sort of multiple things at a time or to repeat phases if they're part of your cycle. You can do the same thing here for the aeration. So whatever number of phases you set and whatever way you've defined them, this is where you're going to tell the system how much air that you want to put in. You also have, of course, the usual options to do DO set points and other things too. And in the manual SBR, now this is what we call manual in the sense that you have to provide all of the control system. It requires custom control of all the settings. So meaning you have to tell it exactly when it's supposed to flip from one phase to the next and when pumps are supposed to come off and on and aeration and whatever it is that you want to do. It usually involves writing some code in either an Axle that is our custom coding or in Python, and that's our new feature that's available in version 8. And you have to do that, and you can control and make it very flexible for whatever you need. It's certainly more work to set it up because, of course, you have to write all the code, but it does allow for the most flexibility. The one time that I remember this was actually really handy was a particular project that I worked on that had 3 SBRs that were in parallel, and it flipped the loading back and forth between the top and the bottom one. And the one that was in the middle had a whole different schedule that involved taking overflow from the top and bottom ones, and it would flip back and forth, and flow went back and forth in different ways. And so we used a manual SBR and wrote a little bit of code to tell it how much to pump at any given time. And that all worked out pretty well. So basically, the little flowchart that you can use to decide which kind you need is just ask yourself, are the phases that are in the simple SBR model the ones that are in the right order for what I am doing? And if yes, then use it. If not, then move over to the advanced. By the way, I'll just reiterate that it shows you those 7 phases there. You don't necessarily have to use them all. You can skip over a few by, if they're not relevant to you, by just setting a duration of 0. So if you're over in the advanced now, are those flexible enough to do what you need to do? Sure, go ahead. And if not, then you've got to write your own custom code to be able to sequence it in the way that you want. Okay, so now when we're setting up the SBR model, there are a few things that you have to do. This is actually not that much different than when you do it normally for any other type of tank that you have. First of all, you have to specify those physical characteristics. So in that case, you're saying how big the tank is, what is the surface area. If you're using some custom aeration settings, those would go in here as well. Specify the details of the diffuser system and all that kind of thing. So you specify basically what it is. And then you need to specify via those menus that we were just talking about the various phases and their sequencing, how many phases and what is their duration and what's going on in each one of the phases. And then all the other settings are the same as what you would normally find in a biological reactor as well. So basically, if you want to change any of the biological settings, if you want to change a growth rate or a temperature sensitivity of one of the biomass types, that will be available to you to do here, and also the settling parameters. So if you have sludge that is a little bit different than our default settings for settling, then you can of course do that as well. And just in case you're curious, you can also source an SBR to another tank in GPSX, either another SBR tank or in fact any other biological tank, so that they can share the same set of biological parameters. Okay, so basically for that simple SBR, as I mentioned, you really, the most important thing that you need to do is specify the duration of the phases that are there and have been specified for you in that given order. So you need to fill in how much it's going to fill when the filling is turned on, how much it's going to decant, how much it is going to desludge or waste, and then what's happening during the aeration, either the specified airflow that you might have or a DO controller. In the case of the simple SBR, you don't have to make any decisions about mixing. It'll know when to turn the mixing on for you and when not to. And as I mentioned, filling, sludging, or desludging, and everything else happens during those pre-specified phases. So for an advanced SBR, again, you have to specify the duration. You can also specify the number of phases as well. There's a little more flexibility there. And then, of course, the fill rate, the decant rate, and the wastage rate, and aeration and mixing for all of those phases. So by that way, you have quite a bit more flexibility in terms of what you want to do. And it can happen in as many times as needed and in any order. And one other thing you should be aware of too is using the time shifting setting that is available in the cycle settings menu of an SBR object. Basically, this is about delaying the beginning of the cycle for any given SBR object, delaying it in time so that it can be out of phase with other SBRs. So in this case here, for this example, you can see here there are actually 4 SBRs in parallel, and so I don't want them all to be filling at the same time and then all to be wasting at the same time. So I want to have them actually 1/4 of a cycle out of phase with each one, so that the flow can go to 1, and then when that one's just ready to finish its filling time, then the next one will be starting, and so on and so on. And you can do that in that cycle settings menu. There's this time shift parameter down at the bottom. So you would start, for example, if you had a 6-hour cycle and you had 4 SBRs, then 6 divided by 4 is an hour and a half. An hour and a half later, your filling should end at that point, and then you would move the flow over to the next one, and the next one would start its cycle. Okay, excuse me. So let's take a look at a demo of what that looks like. And we can see here, this is GPSX version 8.1. 8.01, I mean, sorry. And so you can see here that we are looking at an SBR layout. I just want to point out that actually this is the sample layouts for SBRs. If you go to the sample layouts menu and go to unit process examples, this is the one that I have picked up here called Sequencing Batch Reactor. So in this particular example, I have, we actually use the advanced SBR. If you hold your cursor over it, you can see that. And so if I right click on here, just take a real quick look at these cycle settings. So we can see here that I've got showing that I've got 10 phases. And if I pop that open, we can see the duration of the phases. And for our particular example, some of these have been changed away from the default. That's why they're in blue. And if I go to the aeration settings here, we can see that I'm using a DO controller in this particular example, not specifying airflow directly. And then there's some DO set points been specified during the length of those phases. And let's lastly look here at the flow control menu. And in this case, we can see here that there's this several pages of parameters that tell us when we want the influent to start and stop and do its thing. All right, I'm going to come back to talking about those menus in a little bit more detail after we run this demonstration here. Okay, so now we're going to run a simulation. I got it kind of slowed down a little bit, this particular example, so that you can see it's switching back and forth between the phases very nicely. So now when this is running, this is a case where there are 4 of them in series, and it's going to flip back and forth between them. And what we're looking at in these 2 graphs here in the middle is the concentrations in the layers of the first SBR. So there's 10 layers in that SBR, and this is the solids menu, the one that's here. I'll just blow that up for you so you can see that a little bit better. And this is the concentration of solids in that SBR. And you'll notice, first of all, it flips back and forth between the modes where it's completely mixed, like right now. And then it gets to the end of that. Now it's in the settling phase, and you can see that the top part of the clarifier goes to a low concentration, and then you can see all of the sludge kind of settle down to the bottom half there. So this can be really helpful to use these horizontal bar graphs in order to sort of visualize what's going on with your model and to make sure that it moves back and forth between the phases and between the completely mixed parts of that cycle in the way that you expect it to. All right, so now let's also take a look at this DO profile. So this one is basically the concentration of oxygen in the 10 layers. So during the time when the aeration is happening, you may remember that we're using a DO controller. So that controller brings it right down to about 2 milligrams per liter. So in this particular case, it overshoots a little bit, and then the controller brings it back down. And then during those phases where the aeration is not on, then the DO goes down to 0 eventually. And so that's kind of another confirmation that this is working the way that you want it to, in the sense that during the settling phase and the non-aerated phase, that the DO drops down to 0 as you would expect. Okay, so you can see there's obviously that situation going on, so that you can see the switching along. You can also use our regular quick panels here to just keep an eye on what's happening here. You can see in this particular case that the filling and the decanting and what's going on inside that reactor, some of those numbers go back and forth between 0. It's kind of a helpful visual cue to understand when flow has started and when flow is stopping and so on. And you can see the flow in and out of this particular system there, and you can keep an eye on that mixed liquor. Of course, that's a really small number now because we were doing all of the settling and decanting. Now it's back up to 3,000 milligrams per liter. And you'll note, I'm going to come back and talk about this in a minute here, that of course, this is not running directly from steady state. You actually have to run a bit of a dynamic simulation to get it all the way to the sort of pseudo equilibrium of what an SBR would be doing. One of the things that I find is actually very handy is to be able to keep track of the flow balances. And so the XY scrolling graph is a really good way to do that. So you can see here, for example, if you just keep an eye on this green line to start with, the green line is actually the volume of the reactor. And so you can see it gets decanted down, then it gets filled back up again, and so on each cycle. But it always fills back up to that same point. And I'm just going to pause this for a second. You can see here, actually the red is the decant flow. So when the volume is here and then the decant flow comes to life, it's going to pump that down. And then there's a little tiny wastage flow down here at the bottom. And then this is the filling phase. So the filling comes back to life for its length of time, and then it pumps that volume back up again. And it repeats that same cycle over and over again. So you can then do all sorts of interesting things with your model at this point in terms of changing the phases, in terms of aerating differently or controlling differently, and seeing how that system is going to perform under the various settings that you might be investigating. Okay, so let's go back to the slides. I'm going to touch on, well, most of the important things, various tips for setting up your SBRs. So one thing that I often recommend is as a way to simplify things whenever possible, now we always recommend that in general, is to actually not model all of them in parallel if you don't have to. So if you have identical SBRs, and by identical I mean they're receiving the same loading and they're also physically identical to each other in terms of their volume and so on, then you don't really need to model all of them in parallel, because if they're identical and they're receiving identical flow, they're going to give you, they're going to predict the exact same results for all 4 SBRs. So rather than worrying about trying to sequence all of that stuff, just do one of them, and then you'll know that's going to be exactly the same concentration that would have been in the other ones. There are a number of things that, because of that sort of, excuse me, starting and stopping nature of an SBR, that can make setting it up a little bit tricky. So one of them is, of course, that flow balancing that I mentioned earlier, synchronizing the filling to get that upstream flow to start at the right time and stop at the right time, graphing the results, and a few other things. So let's take a look at each one of these in a little bit more detail here. So you really need to make sure that your cycle balances the amount of flow that goes in each cycle and the amount of flow that goes out each cycle. So the SBR, you know, we do model all of the flow in and out in terms of the volume of the tank. So if you're pumping out more than you're pumping in every cycle, eventually it will drain and you'll end up with a 0 volume. Or if you're not pumping enough out, excuse me, it will overflow. So you will get some flow out of that overflow connection point. So basically, you need to make sure that everything balances properly. It's really actually the number one issue that trips people up. And I get tech support questions about this every so often. So basically, try to take a look at your settings to make sure the same amount of flow is going in that is going out. So if you're using an advanced SBR model, for example, and you click on that flow button, you'll see this kind of a menu here. So, for example, we have some filling happening here, and then we have some decanting happening here, and we have some waste flow happening here. And those correspond to those appropriate points of the actual cycle settings. So what you need to do then is saying, well, I'm going to be wasting at 86,000 gallons per hour for half an hour. So how much volume is that I'm pumping out? And then compare that to the amount that you're pumping in during that original phase, and so on. So we've rearranged these menus in version 8 to try and help make that a little bit more straightforward to understand. So we also need to make sure that the flow coming in is being turned on and off at the right time. So as I mentioned before, you're not going to be filling, you're not going to have flow come into the SBR throughout the entire time. So you want to make sure that you've done that properly. So one way to do it is to use a rotating flow splitter. And so this is a 4-way splitter connected up. And what it's going to do is use the timer-based flow splitting, which rotates through all of the connection points every 6 hours. So if you set it up to be 100% and then 0, it'll basically send all the flow through one of the connection points of that splitter, and then you can get it to rotate around every 6 hours, and then that way it will match up with the syncing of your particular SBR. So that's one way to do it. It's actually not the easiest way. The second way is my preferred method, which is that most of our SBR models have some flow control built into them. And that is done here by taking a look at the label of your upstream object, and then going to that flow control menu, and then using that label here in what we call the influent number 1 pump label. So the code, excuse me, the code of the SBR cycles can actually control the upstream flow object. So in this case, it will ignore whatever you've entered into the influent object menu, and it will set it directly itself to the values that you've got specified in this menu instead. So that pump label there tells GPSX, this is the one that's feeding this particular SBR. This is the one that I want you to turn up and down and time it correctly. So as long as you get your label set up properly, then this will work okay. So you set the influent flow rate here rather than in the influent object itself. Now, I'll just like to really make this point here that all of these pump rates that are specified in this menu, and there's several of them here, these are instantaneous pump rates. Even if you're using a per day unit, it's referring to the actual pumping rate while the pump is on. So in other words, where that is showing 2,000 meters cubed per day for my influent flow, it means that it's going to push it up to 2,000 meters cubed 2,000 meters cubed per day for a period of time, like an hour, and then back down again to 0 and remain 0 for the rest of that cycle. So it doesn't mean that over one day I'm pumping in 2,000 meters cubed per day. It just means that while that pump is on, it's running at this rate. So multiply that rate by the fraction of a day to get your total volume. I just want to make sure clear that that's the meaning of what the pumping rates are in this menu. Okay, so now when we're looking at the output, there's lots of concentrations that go up and down each phase as the pumps turn on and on. And if you plot a lot of data on a graph and then do that for a long dynamic run, it can be really hard to keep track of what's going, and you'll end up with something that looks like this. It's just pretty hard to interpret. So you want to make sure that your communication interval, that means how frequently your graphs are updated, is short enough that you can do what you need to do, but you don't want to have a messy or hard to read graph such as this. So that's why I was recommending, as I showed earlier, using the scrolling XY graph type. I find this to be actually the most straightforward way to make sure my flows up and down are working quite well. You can specify the length of the window that you want to scroll along. It's going to be 1 day by default, and usually I find that's really helpful to get everything rolling. So one thing to keep in mind when we're building a conventional activated sludge system in GPSX, and then we run a simulation, usually what you're doing is you're solving the model for steady state. And if you're doing just a steady state simulation where you have it checked off, you'll end up with an answer that is if this plant has run for a long time and come to its equilibrium. And if you run a dynamic simulation, all the lines should be flat going across. The trouble with an SBR is that, of course, it does not actually have a real steady state because it's going through a cycle over and over again. There's always something turning on or off. And so it can reach a pseudo steady state where it kind of repeats the same pattern over and over again each cycle. And that's really the answer that you're looking for. So the way to get there is you can't use our steady state solver. To do that, you have to run a long dynamic simulation to find what that equilibrium is. And so we suggest running it for like 30 days or something like that, or maybe even longer, at least 3 or 4 SRTs for your particular system in order for it to get to its answer. And the reason that's happening is, of course, the complexity of those systems is not really easy to be able to reproduce at steady state. So, so what we're doing is we're letting the dynamic solver sort that out and come to equilibrium. It's pretty easy to identify when you're at the answer. Just plot something in the effluent, and then you'll notice that the numbers kind of go down and up, and then eventually they'll settle out to their right answer. So the SRT calculation that you would typically do in GPSX is a little bit different for an SBR than it is for other objects. So the SBR, of course, is not wasting all the time, so therefore you can't use it in the SRT calculation. It's really only done during the wastage phase of the cycle. So if you were to define, using the define button, the SRT for your particular system, and you did the wastage off the bottom of that that SBR object, you would find that you get a graph that looks like this. And really, it's this answer here that is your SBR SRT. You only see it. Otherwise, it's 0 all the time because you're not wasting anything. So we don't actually do the calculation until wastage is happening. Then we pop up. And in fact, you can even see that the SRT is going down a little bit during the wastage phase because, of course, we're removing some of that biomass. But this will give you an approximation here, 6 point whatever days for this particular example. So it's a way to kind of get to what you're looking for. Okay, so I see I've used up my half hour plus a few more minutes, so I'll wind things up here. The SBR model is really a complex system, but we've tried to make a simple version that's easy to use and kind of get you started. We have more advanced ones that allow you to do some really quite sophisticated stuff. And it's a little bit more effort to set it up than some of the other objects in GPSX. For those of you who might have a very complicated SBR sequencing that you want to be able to model and you can't figure it out or you can't get it to do what you need it to do, we have done quite a bit of that kind of model customization over the years. So you can give us, just send us an email and we can talk about how that might work. I've done it for several different kinds of things where they had these complex ones, like the 3 of them that were in parallel that I mentioned earlier, where the flow in the middle went through different directions depending on which side was being filled. And I did another one quite a few years ago, many years ago, that was where the cycle was being driven by the oxygen uptake rate. And once that fell below a certain level, the sequencing knew that it was time to move on to the settling phase. and that kind of thing. So if there's something like that, just give us a shout and we can help you put in whatever it is you need it to do.